Okay.
All right, it's all you.
So can I share?
Yeah, let me
Hey,
make
one,
you.
one quick thing, Rick. I'm not going to be able to stay for the whole presentation, so when I drop off, it's not you. It's
Right.
just I've got other things I got to do tonight.
Okay, cool. Thank you. Thank you for the
But I
warning.
wanted to just show up.
Well, thanks. It's good seeing you.
All right, I'm gonna stop my video.
Okay.
Did you give me the host thing?
You have
No.
you're the co-host now.
It won't let me share.
Why? Oh, I made Brian the co-host. He was talking at the time. Sorry.
Okay. Okay, can you guys see that screen fairly well?
Yeah.
Sure. Okay, I'll just keep it in this mode and not go to presentation mode, just be a little easier for me. Okay, so we'll talk. Mike, are you going to record this?
I am recording now. Yes, I am.
Okay, I just
Yep.
didn't see it. Okay, cool.
Upper
So we'll talk about trace 46 and 53. For us old dogs, you're probably familiar with these at least a little bit. So what are they? How do I trace, and what the heck is in there? That's kind of the thing for both of these. So trace events, there are about 1,000 of them actually. However, keep in mind that most of them are things that the internal developers do to test the database. So for example, this 1213 or 20 or 213 does a crash on purpose of the database. And of course, that was to test what would happen if the database crashed at a particular time. So there's a few of them that actually do that kind of stuff. So one thing I like to stress to people about these events is you just don't want to turn them on, just say, gee, I wonder what would happen if I put in this number, that might be the end of your career right there. So be careful. There are probably only these two that you'll ever really use, 46, 53. And of those two, probably the only one you'll really use is 46. 53 is pretty cool. We'll talk about it at the end mostly, but it tells you why, or the how, if you will, of what did the optimizer do while it was optimizing your query, which is cool. But what's usually more important is what happened when I ran something. And that's what the 46 is all about. So I've got, a process, a single statement, a whole thing, whatever. I can turn on trace during that event, during that time period, and see everything that happened. And you will see as much information as Oracle is ever going to show you about something in this trace file. So the 46 trace, as I've just mentioned, it's the most information you'll ever get in one place, and it's excellent for debugging and optimization purposes. It's actually very easy to read. It's just so bloody long that it feels overwhelming. But actually, line by line, very easy to read, very easy to figure out what each line means. Just the fact that it's so repetitive is very difficult. These can easily be megs and gigs in size, even for what appears to be a small run of something. And it shows you event by event what happened. And one of the very key elements in there is the elapsed time. So you can see how much time something took to happen. That really was a bad sentence. You can see how long something took when it occurred. And both in CPU and elapsed time, by the way, for most events, although we'll see there's some that don't have both. And depending on what the event is, you'll see some statistics about it. And also it does show the actual execution plan with stats of the plan. And that's for optimization purposes for SQL, which is what I do primarily. That's really cool. It's a really great thing. One major drawback to the execution plan, however, is it does not show predicate information, which is a real bummer because you can't see which predicate was applied to which step, which can be very, very helpful when optimizing a query, but we don't get it here. Fortunately, we can get it other places, but just can't get it here. So getting the trace file, the key is to trace only what you want. If you get too much information either before or after the thing you're trying to trace, you can be misled by some of that information. So make sure you turn it on and off just before the thing that you want to trace, and turn it off as soon as that event, that thing, whatever it is done. If you can, it's best if you turn it on and off in the code. So you can instrument your code such that like the users can turn on and off trace. For example, Oracle, all their EBS tools actually have a way to do that. So there's a menu item where you can say, trace me, and then trace me not, that kind of thing. And it is good to know how to read the raw trace file. However, that's when you want to go for the details. But we'll talk about, you want to do something like profiling when you get a trace file. So the classic way to get a trace file was, and this has been available for forever, this alter session, set events, and then, you give us that stuff, and you have to put in the numbers. So this is where you put in the 10046 trace name context forever, and then the level. And then the higher the level, the more stuff you get, basically. However, I would recommend you don't even use that anymore. You use the DBMS monitor session trace enable. Now there's actually several functions and procedures inside this package, but that one is akin to the statement that we just saw. So that turns on trace for a particular SID serial combination, which are the first two parameters. So this null are the parameters for the SID serial number. If you put in null, that traces me, that traces the session that's running right now. The second two are waits and binds. Wait events by default are false. I'm sorry, wait events by default are true. Sorry about that. And binds are false by default. I would recommend you put those both to true so that you get all the wait events and you get the binding information. Now we'll see later that binding information is there's a lot of information there, but only a little bit of it is useful. So a lot of people like to not get the bind information because it makes the trace file a lot bigger. However, if you want to get the the bind values afterwards, you can't. Now there is the $$ SQL bind value view, right? You can select from, but that's a $$ view. So it's constantly changing. And if it's been even, a relatively short amount of time between the time you took the trace file and the time you look at the $$ bind variable, they might be different. So if you really want to know what binds were used, capture them while you can. And then the last one is a new thing. This is how often to write out the stat lines in the trace file. Stat lines are those lines that contain the plan, that contain the execution plan. Now, in the past, before this was available as an option, with this version of the query, right, or with this version of the command, the stat lines got written out one time and one time only, and that was when the cursor was closed. And that's okay, I guess. The problem is the stats were accumulation of all the runs. So if the cursor was opened and executed 5 or 10 times, then the stat lines would show you for every execution, all of those stats would be totaled together. Well, that's okay, I guess. But what if the query ran differently each